welcome to online lecture series in organic chemistry, and we are discussing the chemistry of group 18 elements. In this video we are going to discuss the preparation and structure of xenon tetrafluoride, that is XeF4. Now first of all about the preparation of xenon tetrafluoride. Xenon tetrafluoride is quantitatively prepared by heating a mixture of xenon and fluorine in the ratio of 1:5 under a pressure of 5 to 6 atmosphere at 675 Kelvin in a sealed nickel vessel, followed by rapid cooling. So in this way, when the mixture of xenon and fluorine with the ratio 1:5, then it is heated at 625 Kelvin at 5 to 6 atmosphere, then we get xenon tetrafluoride. This is the one method. It can be also prepared by passing electric discharge through a mixture of xenon and fluorine in a molecular ratio 1:2. When xenon is to fluorine, this ratio is maintained 1:2, and when this mixture, through this mixture, when electric arc is passed, then at 193 Kelvin, in this mixture actually xenon reacts with fluorine and there is a formation of xenon tetrafluoride. So this is how there is a preparation of xenon tetrafluoride. Somehow drastic conditions are required to prepare xenon tetrafluoride, because basically xenon is less reactive and therefore high temperature and high pressure is required. Even electric arc is required to carry out the reaction. Now the structure of xenon tetrafluoride. Electronic configuration of xenon and fluorine. For xenon, atomic number 54, distribution of electron 2 8 18 18 8. For fluorine 2 7, and this is the valence shell electronic configuration. For xenon 5s2 5p6, and for fluorine 2s2 2p5. Electron dot structure for xenon tetrafluoride. Xenon is at the center. It contains 8 electrons in outermost shell. Out of it 8 electrons, 4 electrons are shared with the 4 fluorine atoms, and there is a formation of 4 xenon fluorine bonds. So there are 4 bonding pairs. Number of bonding pairs around xenon equal to 4, and these 2 lone pairs available at xenon. So number of lone pairs at xenon equal to 2. Now the steric number, it is number of bond pairs plus lone pairs. Number of bond pairs are 4 and lone pairs are 2, that this is equal to 6. So steric number is 6. It means its hybridization is sp3d2, which is correspond to, or possible geometry is octahedral. It has octahedral geometry, or this is the possibility. So in octahedral geometry there are 6 corners. Out of 6 corners of regular octahedron, 2 corners are occupied by lone pairs of electron, and 4 corners, equatorial positions, occupied by fluorine atoms. This is one possibility. Another possibility is, out of 4 equatorial positions, 2 positions are occupied by lone pairs and rest positions are occupied by fluorine. Out of these 2 structures, the first structure is stable. So according to valence shell electron pair repulsion theory, the 6 pairs of electrons should arrange themselves around the central xenon in such a way that there is a minimum repulsion and maximum stability, and on the basis of this, the first structure is the most stable, where lone pairs occupy the axial positions and there are 4 fluorine atoms occupying the equatorial positions, and this is actually square planar arrangement. So observed structure for xenon tetrafluoride is square planar with fluorine xenon fluorine bond angle is 90 degree. Alternative method formula is H is equal to half V plus M minus C plus A. Number of valence shell electrons for xenon it is 8. Number of monovalent atoms are 4. So 8 plus 4, that is 12 by 2, 6. So H is equal to 6 means sp3d2 hybridization, and there are actually 4 fluorine atoms attached to xenon. It means bonding pairs must be 4, and 6 minus 4, that is 2. There must be 2 lone pairs. So this is the alternate method, and the possible geometry, it is octahedral, but the observed geometry is square planar. Now next, preparation and structure of xenon hexafluoride. So first of all, preparation of xenon hexafluoride. So how to prepare this xenon hexafluoride? So first method, so here xenon hexafluoride, it is prepared by heating the mixture of xenon and fluorine in the ratio 1:20, in a sealed nickel vessel at 500 to 575 Kelvin at a temperature. So this is the temperature, 500 to 575 Kelvin, and at a pressure equal to 50 to 60 atmosphere. So under drastic condition, there is a formation of xenon hexafluoride. So 100% yield of xenon hexafluoride, it can be obtained at 973 Kelvin and under a pressure 200 atmosphere. This is highly drastic condition, and at that condition, drastic condition, we get 100% yield. Another method is, so this xenon hexafluoride, it can be also prepared by reaction between xenon tetrafluoride and dioxygen difluoride at a temperature 40 Kelvin to 193 Kelvin. So at this temperature, there is a formation of xenon hexafluoride. Now third method is xenon hexafluoride, it is also prepared by passing electric discharge through a mixture of xenon and fluorine with the ratio 1:3 at low temperature. So in this way, xenon hexafluoride can be prepared. Now the structure of xenon hexafluoride, that is XeF6. This is the electronic configuration of xenon and fluorine. In xenon, 8 electrons present in outermost shell, and fluorine 7 electrons. Valence shell electronic configuration 5s2 5p6 for xenon, and for fluorine 2s2 2p5. Electron dot structure, here xenon is at the center, 6 fluorines forming single bond with xenon. Out of 8 atoms present, 8 electrons present in the outermost shell of xenon, 6 electrons are contributed towards the formation of bond with 6 fluorine atoms, and pair of electron, it is available at xenon, that is the non-bonding pair. So here with this xenon, there are 6 bond pairs and 1 lone pair. There are 6 bond pairs and 1 lone pair. Steric number equal to number of bond pairs plus lone pairs. So bond pairs equal to 6, lone pair is 1, that is equal to 7. So 7, steric number 7 means its hybridization is sp3d3, and possible geometry is pentagonal bipyramidal, where in this pentagonal bipyramidal, and actually this is the best arrangement, pentagonal bipyramidal, it is the best arrangement with xenon at the center with 6 fluorine atoms at 6 positions as shown here, and one of the position of pentagonal bipyramidal, it is occupied by lone pair of electron, and this gives the distorted pentagonal bipyramidal structure. This is not regular but distorted pentagonal bipyramidal structure, but the observed structure is distorted octahedral. It is like this, distorted octahedral. So this is actually octahedral structure. It is because of the fact that lone pairs require the less space to occupy than the bonding pairs, and therefore the structure of xenon hexafluoride is distorted octahedral. So lone pair, it is occupied over here, and the regular positions of octahedron, these are occupied by fluorine, 6 fluorine atoms. Xenon, it is at the center, and as lone pair requires little bit less space to occupy, somehow it is occupied like this. This arrow shows the direction of fluorines. So its observed structure is distorted octahedral. Alternative method, H is equal to half V plus M minus C plus A, half 8, it is the number of valence electrons of xenon. Now this 6, it is number of monovalent atoms, that is 6 fluorine atoms are attached to xenon. Minus 0 plus 0 means positive charge is not there, negative charge is not there. So this is equal to 7. So it means H is equal to 7 means its hybridization is sp3d3, and sp3d3 hybridization means the expected geometry is pentagonal bipyramidal with bonding pairs equal to 6. Why 6? Because 6 fluorine atoms are attached to xenon. It means bonding pairs must be 6, and 7 minus 6, that is equal to 1. So there must be one lone pair. This is the alternative method to find out the bonding pairs and lone pairs. We can find out by drawing the Lewis dot structure or electron dot structure, or applying this formula. And from this it is clear that the xenon hexafluoride, the expected structure for xenon hexafluoride, it is pentagonal bipyramidal, distorted pentagonal bipyramidal, but observed structure is octahedral. So this is about the preparation and structure of xenon hexafluoride.